Hello guys, welcome back to my channel. I'm your host Rasan Khuram and I'm back with another video in the series Marketing Analytics with Python. Today we are going to discuss about correlation analysis for marketing data sets. We are going to discuss the concept of correlation analysis and how is it important for marketing data sets or any kind of analysis where you are kind of building a regression model or predictive model, or even you want to understand the basic relationship between two entities, two characteristics, then correlation analysis is the answer to go for. So why correlation matters in marketing? Correlation helps customers uncover which metrics move together, like which metric in the data set, a column is affecting the other column. Does higher promotion spending increases profits? Are older customers more loyal? Do repeated order correlate with total profit? So these are some of the questions that we do have at hand and that can be easily answered with the help of correlation analysis. Why? Because with the help of correlation analysis, you are actually able to relate one column metric to another column metric and say they are correlated. Either they are correlated or they are not correlated, and we can actually do that quite easily in Python. And here the key thing to remember that the value of correlation analysis is taken from -1 to +1. The positive one shows there is a strong positive relationship, like one increase will definitely increase the other one. Negative one will show a strong negative correlation, like if one increase the other one will decrease. And the values that are close to zero, either in positive turn or negative turn, will be said something like they don't exhibit or have some sort of correlation between them. But how we are actually able to do it in Python programming, I'm going to teach you right now. So here we have it. First of all, we are importing Seaborn, that is used to generate statistical plots in Python. Then we have like Matplotlib imported, which is for normal plot customization, this sort of stuff. So the first thing we would like to do is to drop any non-important numeric type column. In our case, it's customer ID because we are dealing with correlation analysis. So customer ID is unique for every customer. So this doesn't make any sense to include it in our correlation analysis. So with the help of this statement, we are passing two input argument to this method drop. The first input argument is the column that we want to drop, and the second input argument is the axis. Obviously, the axis here is the column, so one denotes column and zero denotes rows. So here we are dropping a column. Once we drop it, what we are actually doing here, we are actually calculating the correlation. So this method .corr actually calculates the correlation between those entities and will create a matrix, and that matrix will be stored in the form of a data frame, which calculates the pairwise correlation between all numeric columns. So this is what it looks like. If you go back to the theory, we say that you know what, strong one will have a strong positive and negative one will have a strong negative, and the values that are near to zero represents no correlation at hand. So this is our main area of interest or main matrix that we want to study the correlation. And you can see that some of them are actually 0.5, which shows a strong correlation. But what if we actually want to display it in a visually appealing and easy to digest form? We can actually do it in the form of heatmap, and that is exactly what Seaborn library allows us to do. So we have this metric at hand, and yeah, we also kind of rounded off the values to 2 decimal point, because otherwise it would have displayed a lengthy decimal point integer, which is of our no interest. So we rounded off to 2 decimal point. So once we have that, so first of all, we set the figure size, and we are using the function heatmap of Seaborn library. So we have like sns.heatmap, and first of all, we pass the data. In our case, it is core. If you recall, the core is the new data frame that we made that contains the correlation analysis. Then we put anot is equal to 2. It means that we want to display the actual value on top of every cell. And then we set the color map to cool warm, which is set for like color palette that you're currently seeing here is because of this cool warm. And finally we are setting line width is equal to 0.5. So this is like the line in between the cells that is used to have this statistically appealing visualization. And once we have that, we are good to go. Then you add other details such as titles. We'll put x takes to rotation with 45, so it means that the labels on the x-axis will be rotated 45 degree. So once you do it, you will see a graphically visualization, something like that, which is graphically appealing, but it also quite helping in understanding where we do have a strong correlation. Now you can see that subsequent order profit do have a very strong correlation on total profit in increasing manner, and churn rate, which is has a strong correlation in decreasing manner. So if the churn rate decrease, the profit is going to increase. So this sort of stuff. So this is how you can actually have a correlation analysis in Python library. So high correlation between total profit and subsequent order count, repeat customer matters, weak correlation between age and promotion value, discount appeals across ages. So it means that discount will appeal to all ages irrespective whatever the age that customer holds. I hope this video have been helpful. I will catch you soon in the next video.